In section 11.5, we're going to look at this briefly. We're going to look at something called mathematical induction. And basically, it's a way to show that some kind of formula works for any value n. We're not going to fill in the value n. We're going to say it works for any number you can possibly think of, n. And when we use the letter n for a number, we mean that it's going to be a natural number. A natural number you think of as the counting numbers. It starts at 1. 1, 2, 3, 4, 5, and so on and so forth. It should go on forever. So when we say that something's true for any natural number n, it means any positive whole number starting at 1 up to past 1,000,000, anything you can possibly think of, up to infinity. So, how does mathematical induction work? Well, it first says, let's make sure that it works for the first value. Let's show it's true for just the first value when n equals 1. So that means plug in 1, make sure that it works. Make sure that both sides are equal. Step 1. Step 2. Step 2 is, okay, well, let me assume it is true. Assume it's true for any n. So assume whatever statement they gave me is true. And then we want to show that it's true for the plus 1 term. So we'll assume it's true for just k, some number k, and then we want to use that to show that it also is going to be working for when we have k plus 1. So if we assume it's true for one term, we want to show it's true for the one after that, the k plus 1th term. Once you do that, what we'll do is we'll kind of play around with both sides until we get the same thing on both sides. That will show that the statement is true for the k plus 1 term. Once we do that, then we've done what's considered a proof. So what that is going to be considered is called a proof, and it's called a proof by mathematical induction, and you're saying that the statement is beyond a shadow of a doubt true, and you've proven it mathematically.